Okay. Our next talk has the interesting title, Fuzzing the Corporate World. You probably want to...
Yeah, in 2 minutes. Setting things up.
Okay. The next speaker is Gadi Evran, who works for the security vendor Beyond Security, which is based in Virginia, USA. So he is going to talk about things he knows about, because, well, fuzzing the corporate world just means, well, just put random data on some ports you find. This is great fun, as I can report from my own experience. So if you give a talk, be sure to have your Bluetooth dongle handy and have a tiny little program that just looks for cell phones and then fuzz them, which significantly reduces the annoyance of people just having cell phones ringing while you're giving your talk, which is always annoying. So this is again a call for people with cell phones in the audience to turn off their cell phones. Thank you. Okay, our speaker is an offender here, as we see. He has 2 cell phones.
Well, one for abroad, one that's roaming. So.
I see. So anyway, Gadi has also experience with the governmental world. He at some point worked for the Israeli government as a security officer, if that's the correct job designation. And then... Well, that's scary. Anyway, if you're ready, I'll give you the mic.
Thank you, thank you. You actually gave a biography, that's cool. Okay, before I go to the presentation and link the laptop, I want to waste about 2 or 3 minutes to talk about fuzzing, because this lecture is not really about fuzzing. The technological parts, I think there was also a presentation by Ilya about fuzzing yesterday, maybe? About technology itself and how it works, and my purpose is not to tell everybody yet again how to do fuzzing and what types of input to send. Well, I'm actually going to do that anyway, but in general, that's not my purpose. My purpose is double. One, to show how organizations actually use fuzzing, whether it was 5 years ago and whether it's today, and to highlight the changes in fuzzing over the past few years that have made it fuzzing, that is, a part of some organizations or some corporations actually do fuzzing today. And the organizations that don't do fuzzing, why do they use fuzzing? What do they use fuzzing for? Why do they need it? And what they ask their vendors to provide for them. So, 2 or 3 minutes, bear with me. What is fuzzing? I'll just pick somebody arbitrarily unless somebody speaks up, so. Okay, you, doing your email. What is fuzzing?
Sending random data?
Here you go. I'm setting up my laptop, it's cool.
Okay. Sending random data to some port and show what the service is doing.
That was quick. Okay. Sending random data into ports and seeing what the server is doing, meaning that the only thing I can actually fuzz is a network service?
No, you can fuzz. You can fuzz things like browsers.
Like what?
Browsers, web browsers.
Sorry. Okay.
Keep on the interview.
So you can fuzz browsers. Are browsers and network services the only things on the planet that actually take input?
No.
Okay, pass it over to... Yeah, thank you. Thank you very much for your kind contributions on fuzzing. Now, what else can we fuzz? What else takes input?
Yeah, anything, any program takes input because it's
Any
really
program takes input?
Yeah, most.
Hello world takes in, well, actually, hold on now.
Okay, can somebody name a few who doesn't take input, just
Hello,
output?
hello world. I'm serious here. Hold on, can you pass the microphone?
I mean, Hello World takes it.
First of all, name.
Shane. Hello World has input. You have environment variables. You've got limits on resources. You know, memory and the output goes to special places. So there's all kinds of ways you can manipulate the environment that Hello World runs in. So I would agree that any program does have input for sufficiently convoluted definition of input.
I'll go for that, but this is when I stop the discussion, not just because my laptop is ready. That is just, woo! Hold on. No? The wonders of function F5. Okay. Not just because every program in some way takes input, or should we say is dependent on some environmental inputs that we can somehow play with, manipulate, or modify. Isn't that the same thing? But because we use programmable computers. We use computers that are for more than one purpose. Nearly everybody in this room, except for me, has some sort of single-purpose computer on them. Does anybody have any idea what they are? Single-purpose computers in this room. Nearly everybody has them. That's correct. The watch. Okay, the microphone, yeah, okay. I think that there's actually nothing smart in the microphone. It's just purely, no? Oh, you want to give the microphone to somebody. You're not giving the
There's
microphone.
crypto in here, so make no mistake, there's a single-purpose computer in here.
Other than the watch. No? A cell phone might be, take the mic? Yeah. The microphone?
Oh, yeah. I was saying, well, cell phones, although nowadays a cell phone is getting more and more like a programmable computer, but original cell phones could be considered as a single-purpose computer, I guess.
No. And not because I'm annoying, I am, but because, seriously, I don't really believe that other than the very, very original cell phone when they tried to redo Star Trek, was anything but, I mean, today, can you actually name many devices in the world that don't have some sort of software on them that you can download and modify?
Well, electronic devices, I wouldn't say many, no.
Even this thing has software on it that I can modify.
Yeah.
Right? So,
Yeah,
to
totally.
get, well, not to, I mean, I'm beating around the bush. Basically, the main problem we have security issues other than design is because we have the programmable computers. Now, that's why I'm repeating this is for the very simple reason that fuzzing is, if we have to simplify it, and we are going to define it in a second, it's a testing technique. And not just a testing technique, it's a black box testing techniques, that means basically we have no source code. We have no, I mean, in theory, have no actual data on the software or any previous hints of what the implementation looks like. Okay? Now, I don't believe that definition. If we read this Wikipedia definition for a second, fuzz testing or fuzzing is a software testing technique. As you see, I copy-pasted, and it kept the HTML. Is a software testing technique. The basic idea is to attach the inputs of a program to a source of random data, fuzz. If the program fails, for example, by crashing or by failing built-in code assertions, then there are defects to correct. Wow. Okay. I disagree. Can anybody tell me why? Nope. Well, what this guy said, actually, what's your name? What? Christoph, okay. What this guy said was basically take input, throw it at a program or a service, as they put it, and see how it reacts. I believe that defines black box testing much, much better than just attach some sort of input to a program. So first of all, we assume it's a program. Source of random data, I don't agree that it's random data. and see if it fails. I don't agree if programs should fail. It's not always by crashing or failing built-in code assertions. And this is where we're going to actually start going over how corporations can take all this and use it. Because so far, to be honest, what have we had in the fuzzing world? I mean, in the late 80s and mid 90s, we have had Bart from a university in the States, that I forgot the name, Barton Miller, who took pretty much random data, attached it to programs, and crashed them. And that was pretty cool. But most fuzzing tools that came afterwards, I won't say that weren't very good, but were amateurish in the fashion that they were on-built. Meaning, if I build a fuzzer, it's for me. And I'm the one that was going to use it. I didn't expect for that fuzzer to actually be used by anyone who doesn't know what code looks like, who won't be able to tell if a function should end somewhere where it even begins. And the whole idea of corporate fuzzing is, in most cases, again, there are different areas where that can actually be attributed. The whole idea is they don't want to look at source code. They want to use fuzzing today as a sort of tool to help them mitigate, eradicate, terminate, whatever you want to call it, bugs in software. I mean, I'm not sure what everybody here does, but as security people, we keep getting pissed off at software vendors for saying, how the heck can these guys still have this basic Stack Overflow in their software? I mean, do they even do any type of input validation, not to mention proper input validation on their software? And the answer is usually no. But that did not change that fact until we could provide these corporations with some sort of tool to say, hey, if you use this, you'll get rid of most buffer overflows. Now, I'm not saying that you'll get rid of all buffer overflows or of all bugs whatsoever, but you will definitely get there by eliminating most of the simpler bugs or vulnerabilities and moving on. And the whole point is they're pointy-headed, like this lecture. If anybody expected a technical fuzzing lecture, then I apologize, and I would forgive you if you get up and leave right now. The point of this lecture is how fuzzing actually gets into the corporation and how they use it. So let's move on now that I wasted 5 or 10 minutes. So random input, right? I disagreed with that statement because, in my opinion, random input, as useful as it might be, is long gone. Today, for any fuzzing to make, you can still find a lot of vulnerabilities and a lot of bugs, but just sending some sort of random input at the program and seeing what happens, that's true. But it can be a lot smarter than that. And then we go to sensible input, which means, hey, let's look at what the program expects to see, or what we might expect to send a program, and use that instead. Then we move to block-based input, which basically Dave Aitel introduced a few years ago, which says, hey, let's send requests that the program will know I'm generalizing here, but let's send requests that the program would know to expect, such as if we use HTTP, we'll send get file.name, HTTP 1.0, whatever, and end the request, and pick some location in that string, say the extension of the file name, and fuzz that area, or other areas. We can also call this value manipulation in a way. It did not really teach the fuzzer the protocol. It did not really teach the fuzzer everything that it needs to know if it is to be a smart fuzzer, as people call it today, but it was a step in the right direction. And protocol-based input is basically, hey, and I chose these names. They're not necessarily representative of what people actually talk about. Protocol-based input would actually mean, hey, let's teach the fuzzer. Let's train the fuzzer. Let's make sure this fuzzer knows what it's talking about. So when it sends a GET request, it will also know what POST is. Okay, again, we choose HTTP as what we want to test or fuzz. Kind of boring nowadays, but still. And we want to be able, for example, if we use FTP, to tell the fuzzer, depending on the purpose of the fuzzer, don't just try and fuzz the username and password. Try to be a little bit smarter than that. Once we establish the protocol, we can establish a session. And FTP does require sessions, or stateful, or whatever else you want to call it. And basically, hey, we send the username. Let's send the username yet again, see what happens. Or we sent this particular protocol, the particular implementation of this protocol, some sort of request for a key. We received the key. Let's use a different one. see if we can try and, because we already support the protocol, try and cause some sort of logical flaw or session-based flaw that will actually trigger something in this application. So fuzzing is not just random input. In my opinion, random input cannot be just dismissed, but it can definitely be used a lot more smartly than just dumping random shit into, sorry for saying shit, fuck, okay. Just dumping random shit into parameters like Barton Miller did back 20 years ago. The technology advanced a little bit since then. Now, what's smart fuzzing and why all the buzz? Can anybody tell me what, really in simple terms, because I want to get through all these slides in about 2 minutes because now I'm actually on the clock. Can anybody tell me what smart fuzzing is? Okay, you. Don't sit in the front row ever, ever. The cool guys are always all the way in the back saying, look at this fat fellow over there telling us what fuzzing is. Come on, I wrote a fuzzer when I was 8 years old.
Okay, I think smart fuzzing.
You mean you know what smart fuzzing is and you did not volunteer to answer? I'm shocked.
Okay,
No, I want an excuse right now. Why didn't you just raise your hand and say, me, I know what smart fuzzing is. I'm scary, ain't I?
Doesn't matter.
Okay.
Smart fuzzing is if I take a look what the program expects, and only some parts are random and the other parts are what the program expects. So you can
Do what the program expects.
yeah.
Well, actually, guys, it's smart because they actually did sum it up in one line and did not know where to go from there. Because, hey, let's see what the program expects. Let's not just send stuff and see what happens to the program, see what or the environment, see what the program itself expects. And why this is so smart is because if we know, for example, notice I'm not going too far ahead here. Let's choose HTTP again. If we know what HTTP looks like, again, we can actually not just send blah, 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 blah 255 times, or 1,000 times, or whatever, how many times we want. We can do something smarter which will likely cause the program to fail. And we will go more into that again, but that's a little bit of repeating. Smart fuzzing, in my opinion, is doing a lot more than that. It's forgetting the idea that the fuzzer is actually a client. Can anybody tell me what they think I mean by that? Because I'm not sure what I mean by that. No, okay. Well, by meaning that of a client, when we use fuzzing, again, there are many different approaches. We can use proxies, we can use man in the middle over a router, or whatever else we want to do, to watch the traffic, analyze it on the fly, and generate whatever it is we want to fuzz on the fly from the packets we observe. That is very useful. Of course, we'll naturally never pass more than 1% of the protocol usage. And if we have some sort of printer bug like we did in IIS, we're screwed and we'll never find it. But usually what you do with fuzzing is you emulate the client, meaning if we go with HTTP, I'll try and be a browser, right? I'll try and send something that will crash the server, or the other way around, naturally. And I'm saying, hey, that's smart. And we can probably make it smarter. We can probably send in requests. We can do an exhaustive test and test what billions of different combinations and eliminate some of those that are really repeating themselves or are kind of redundant and get down to millions of combinations if we're really smart. That's still just sending stuff in and expecting for something to happen, an exception maybe. And you know what? That's kind of getting on my nerves lately. What's so fucking difficult about doing something very, very simple, which many of us have done over the past years, such as putting some sort of debugger on the host of what we attack. That would be a very passive approach. Put the debugger over there, wait for the exception, and see what happens. Now, what if we did something a little bit extra? For example, we monitor the CPU usage. That's very, very simple to do. It's not always very simple to actually take that information and do something with it. We may be able, for example, to take that information and lower or increase the number of requests we send per second, but taking the information about CPU usage, memory usage, looking for perhaps memory issues, not necessarily memory leaks, is not very simple. Using some sort of software on the host itself, which can, for example, trace the binary, be a profiler, see what's actually happening, Or try to count, hey, how many times did we actually discover this particular path in the tree of the binary? What functions did we access and how many times, and what type of request did we send? Try and be smarter about our fuzzing is something that not many people do when we're still stuck mostly in the world of clients. So in my opinion, smart fuzzing is anything that is beyond just sending requests all the time using the client, but hey, the road is still ahead. People say today that there is not much ground to cover yet with fuzzing. We have done pretty much everything that we could, and from this point on, it's just repeating ourselves. I'm not sure that's true, but for now, smart fuzzing actually means what this guy said. Send in input that's a little bit smarter, which means, hey, don't send all the exhaustive protocol space. Send first the request that actually might trigger vulnerability in our experience. What is more likely to trigger buffer overflow, an off by one, or any other type of vulnerability? So that's smart fuzzing. Yeah, that wasn't 2 minutes. Is smart fuzzing up to the task? Okay. Exhaustive versus targeted, I believe we covered that. Software testing versus security testing. Can anybody tell me, actually, yeah. Can anybody tell me why there is an actual distinction here between software testing and security testing?
The difference between software testing versus security testing is software testing is more likely to be from the user side. Security testing is via the, let's say, what input can be, or mal input can be used to, or malicious input can be used to test the software, or beyond the let's say, requirements of the software itself.
So basically, if I can take what you said is correct, you're on the spot. But if I can take what you say, change it, alter it completely, and use it for my purposes, I would say that software testing is regular testing. We want to find bugs, period. Security testing is much like software testing. We want to find bugs, but we much rather find bugs that are exploitable. And then we look for vulnerabilities. If you talk to QA people, and this is where we start our actual discussion of how organizations use this, they will say, what? You're not testing for everything? Seriously? And I will say, no, really, I believe in exhaustive testing. I want to test as much as possible, but I actually want to get results by tomorrow morning. And if I want to get results by tomorrow morning, or you know what, fine, I'll test for an entire year, 12 months now, but how about for the first day I test for things that are very likely to exploit something? Would that be useful? Can I go over CVEs of the past, look at vulnerabilities that often happen in certain types of applications that use them first, try to exploit them first? Does that make any sense? And to QA engineers, it doesn't. And no matter how much we can reiterate the subject, it simply doesn't. And that's where the problem starts, because say you take a fuzzer, say you take Spike, okay, or any other type of fuzzer, and give it to a QA engineer. Now, QA engineers are very good people, but most of them really do not want to see code in any way. They want to see an exception, period. Now, not all vulnerabilities in any way will trigger an exception. You need to monitor the program a lot smarter than that. And I'm not just saying monitor it with a profiler, like I said earlier, but actually, how about looking at the logs that the software produces? Why not actually check what logs you want to be produced to begin with? And this is a big issue when talking to corporations. Now, in the year 2006, almost 2007, we have more reliable tools, meaning Spike was great, but you had to be Dave Aitel to actually make it work. It kept crashing. So, I mean, I see some people here actually use Spike. That's pretty cool. So once we provide with more reliable tools, corporations can actually use them, which is great. So I'm waiting for somebody to actually say, what do we care if corporations use fuzzing tools? We will them because it's fun. New frameworks, better frameworks, which means we can provide an organization with, say, a fuzzer, which is an engine, and drive that fuzzer using, say, XML or some other type of protocol building aid that we can just tell them, hey, you have a proprietary protocol, that's great. Just enter the specs in here, and we'll fuzz it for you. So we have better frameworks that will help us not just repeat our technology and rebuild our technology and build new engines, but actually use something that will last and they'll be able to teach the people after them and preserve the knowledge inside the organization. And then we had another advancement which comes in the hundreds of thousands of dollars, actually, per, which is commercial fuzzing tools. Now, some of you probably say, fuck that right now. But how many people here actually work for big organizations? Raise your hands, come on, I know we have all sold out a long time ago. Okay, I'll take that as that we are all either under 18 or work for bigger corporations. So, thank you, traders. So, organizations would usually choose to use the obvious, which means, hey, let's choose something that will have support. Can we get support for Spike today? Can we pay for support for Spike today? No. Good luck. I'm not sure I want to pay for support for Spike, but thank you very much for offering. And actually, that's the way it works with open source. We have a lot of open source consultancies. It offers support and other such liability issues, cover such liability issues for big corporations that they can actually use open source. One of the big issues with corporations not using open source is they're saying, who's the mother or father of this tool? Who is going to actually help me if I have problems tomorrow? How do I know this tool doesn't disappear tomorrow and the maintainer goes to the university or something? So this is actually critical. And the commercial world, although expensive, actually brought in more manpower, more development, and more ideas, as well as money, than the fuzzing world ever had. It moved really from homegrown tools to the commercial level. So in the past, we had fuzzing enthusiasts. I guess some of us here, right? Corporations with fuzzing enthusiasts, which means, well, there was Matthew France for Cisco. Anybody ever seen his presentations or read his stuff? No? We had people at Microsoft. We had people in a lot of places. Symantec has a person who is really great. Orlando, if anybody knows him, who does fuzzing. But basically, it was at the same level. They developed their own fuzzing tools and used them in their own software security teams in order to find vulnerabilities once the products are completed or in testing for some odd reason. They were not the actual development team. They were not the actual QA team. They were lone wolves. They were hackers. Now, right. Now, Cisco, Microsoft, Juniper, AT&T, Symantec, they all use fuzzing extensively. I'm not sure if this surprises anybody because fuzzing has been here for years. Nothing new, right? Why all the buzz in the papers all of a sudden, right? I mean, for people who've worked on fuzzing for, say, 10 years or 5 years or even 2 years, saying fuzzing is going to save the world kind of pisses us all off, right? What's the big idea? So the usage right now is no longer limited to one elite group or another, but rather integrated into the development process. So everybody starts talking about it. It's new now. Live with it. Now, one of the biggest issues of integrated fuzzing into the vendor development process or the cycle is to be actually be able to work with other security QA tools. There are no real security QA tools today, but it's a world that's forming right now, and 2-3 years down the road, I can see a SUNS certification for a security QA analyst or something like that coming, and people will actually take it. So how do we work with other QA tools, such as, for example, code analysis? Should fuzzing, which is black box testing, just sending input and seeing what the output is, actually work together with code analysis, code auditing, static analysis, splint? How do we make that work? Because if the corporation currently uses some sort of tools, they want to integrate it all together and get the maximize their results. So we can also put them in as standalone tools. Say, hey, establish a new group within, say, I'm just arbitrarily choosing Cisco, and that group will check with fuzzing, we'll check with code auditing tools, we'll have false positives, but a lot of results. You'll have no false positives, meaning exceptions, but nearly no results, and we'll have fun. So where do you integrate them, and what are the challenges of integrating them with the QA environment? So now that there are really little to no excuses left for vendors to actually test the software, and let me actually read this and then move on. Such testing cannot eliminate all bugs of all types, but it can eliminate most of the lower hanging fruit and some of the more difficult to discover and exploit vulnerabilities. It's all about raising the bar. Now, once the organizations can actually raise the bar, they will go through all these hoops, which are quite serious for organizations or corporations or any software development company which is more than 3 developers or 10 developers, and try to integrate the fuzzing. Now, how do we actually do that? One vendor, and in this case I'm looking at Microsoft, I'm not sure this is exactly what they're doing. I collected this from talks with different people who work at Microsoft, things they write. If you look at the web and see what Microsoft actually says they do, you will see fuzzing pretty much clearly in the whole fuzzing or security testing or anything else that comes from Microsoft. So first of all, one thing that I've heard from them is fuzz each protocol on its own. They don't want to just take some sort of software and throw the fuzzer at it. If it uses both HTTP and BGP, I'm not sure if Microsoft has anything that uses BGP, then test each of them on their own and see what happens. Maximize your testing. Find all you can. Reach coverage as close to 100% as possible, which means put people on the fuzzing. Don't just run and forget, right? That's the one thing we discussed that corporations usually can't do. Microsoft is different. Fuzz whatever malicious input a user can provide. File formats, network traffic, anything that you can actually think of should be fuzzed because, hey, this is the lower hanging fruit. This is something that can be done, should be done, and there is no excuse not to do, in my opinion, again. Now, they actually do something interesting. They call fuzzing automated runtime vulnerability discovery. As in, they don't just use the random input, they feed the application some stuff that it might expect. Hey, a GET request. Wow, HTTP. Now, some stuff that this is not just Microsoft, but some stuff that we have seen when trying to sell our own fuzzing tool beyond security is that corporations or organizations require a little bit more than what, each and every one of us can build a fuzzer for ourselves and it will work great. But once it actually goes out and tries to do some more for more people who are not us, it needs some extra. So state or session-based, doing A in order to do B in order to do C, right? If we need to establish some sort of a session. Knowledge, I also call this a little bit value locking. Know what the protocol problems are. So if it's query strings or hidden fields in HTTP, custom extensions for SIP or anything else, we should probably know about this and make sure the fuzzer can actually cope. Define what a bug is, as in, if different applications can show us different bugs in different fashions, don't limit ourselves just, for example, to exceptions. That would be silly. Although exceptions means, hey, there is no false positive. Something happened here. We've seen false positives before. On Backtrack, for example, 6 months ago or 8 months ago or so, somebody said, I found this really amazing vulnerability, okay? When you run out of hard disk space, this thing crashes. Well, if you have a DOS vulnerability when you're out of hard disk space, that's a different problem altogether, and I don't know what, nobody's laughing. I guess my jokes are really, really bad. Now, we need to be able to train the fuzzer, okay? Change the fuzzing accordingly to what we find in the field and what we need to actually do. We need to tie in, and we started talking about this, and I just skipped ahead without actually finishing the sentence. I will get back to that. Tie it in with proxies if we want to, for example, sniff the traffic, build the fuzzing as we go. Again, we probably won't reach more than a very low percentage of fuzzing the protocol, but we may find stuff that we won't find by just teaching the fuzzer the RFC. So tie it in with proxies, code coverage, human auditing. Hey, we know we have a problem only when we set GET requests, and we are not sure about the code here. Can you please check only that? And can you try and please add some sort like the word blah before your request, because only then we'll actually see them? Can you? Oh, thanks. So it actually matters that this whole stuff ties in together, and tying it all together is one of the challenges. Complete fuzzing. I'm not really sure how we all define complete fuzzing, but it's an issue. Because, hey, can we really do exhaustive testing and test for everything? By the way, for people who did not hear it at the beginning, this is not a technical lecture. If you want a technical lecture on fuzzing, this isn't it. Please don't be disappointed later on. Yes, I know, it's nearly over, but hey. So can we really afford to do exhaustive testing and waste several months on trying on whatever type of fuzzing we're trying to do to find the bugs and every possible bug, because the printer bug in IIS would not be found otherwise? Or can we just look for what the low-hanging fruit is and find the things that are more kind of, well, duh. I didn't actually say that. Yes, we have to do exhaustive fuzzing, because can we afford not to? That said, unless we are actually software testing engineers or QA engineers, there is no reason for us not to do other types of fuzzing. There is no reason for us not to do other types of fuzzers that will test for specific issues. So catching failures, we discussed that. And finally, and this is a quote, fuzzing finds many bugs and security vulnerabilities, but it cannot find them all. That goes without saying, as hey, it's testing, it can only prove bugs exist. Now, I want to actually move forward and discuss how banks and telcos use fuzzing. So let's go over this real quick. We need to use both block-based and session-based fuzzing. Use test automation, as in traffic analysis, although that will miss stuff, and then do the actual fuzzing that we are used to do. Do them both. Don't be shy. And this is kind of an issue. Can anybody actually tell me if they ever, I mean, doing this is not very difficult, but can anybody who talked to a SIP vendor actually tell me if they ever got any formal protocol description for SIP and if they weren't told it's impossible? I guess nobody here was actually involved with that, but sometimes people say, I don't know what this protocol does. We just coded it in. I mean, are we supposed to actually document every command? No way. And actually, in some cases, it's not really practical to document everything. So it's very important to do a lot of stuff together and see, hey, what's this thing I'm seeing on my sniffers now? Was that there before? And actually, just as an example, this can actually be discovered on our own if we fuzz FTP. It's not that difficult, as an example, to send all possible strings up to 4 characters and see if any new command was added. Of course, this won't cover everything. We can try and fight the machine and do things on our own, but sometimes we have to cooperate. Now, QA-level fuzzing tools, we need exceptions. We don't need code. We need to be able to jump up with a huge screen saying, there is a problem. In order to fix this problem, take this file, which saved the exception information, debugging information, whatever information you like, and send it to the developing team. Do not look further. Click next. So simple to use. We'll finish its run in a very reasonable time frame, say tomorrow. And distribute to QA teams, as in, we can have cool fuzzers, we can have things that do stuff that's very, very elite. But having actual fuzzers that we can send to the QA teams around the organization so they can do their own fuzzing and deal with some of the stuff on their own is pretty cool. So we can either send the tools or have an infrastructure for the development or QA teams to use, which is kind of cool on its own. Now, this was actually a surprise for us, that selling fuzzers that beyond security, we found out that the vendors don't always actually want them. It's the banks, the telcos, other large corporations that actually want them, because as far as vendors go, they will reach the decision of using fuzzers or other security testing tools when they do, and when they decide to actually add them to the budget criteria under firewalls or antiviruses or whatever. But banks and telcos, I mean, if you are a bank or a telco, what did you do or any type of organization, what did you do when you were supposed to, for example, choose a web server? You looked, I mean, if you even cared about security, you would try and stress test it, right? See if it can stand up to a lot of requests. You would try to check the configuration and whatever else it is that you can do. If it's an antivirus, see if it actually catches viruses under different conditions. But basically, you would go to Bugtrack or wherever else on the web, security team, wherever, and say, let's see how many other vulnerabilities this product had in the past. Let's see how long it took the vendor to actually release a patch. Now, these things are as inaccurate as can be and don't really say much, but that's all we could do. And they're now able to better decide on the security and stability of products, meaning, hey, we can test the product, come to the vendor and say, you want us to buy this? why do you have this gaping security hole called 255 bytes in a row, A's? And I don't know, fix it, we'll consider about buying it. And then we can actually add security to the list of demands, and not just by features. For example, antiviruses add a lot of features such as spyware, jokeware, blowware, whatever, in order to be able to sell products, and then it appears on the marketing list of when we shop for antiviruses for corporations. Now I can actually say, no, we will test your product, and if it's up to scratch, we'll buy it. And this was a big surprise to us, selling Bstorm. Now, a discussion point, really, and we'll go through this kind of quickly because this is a couple of things that fuzzers can do today. Certifying products. In the past, this was very, very difficult. I mean, try to imagine having 2 or 3 reverse engineers and a couple of good code auditing teams going over some product and trying to determine if it's up to scratch to whatever guidelines it is you put in place for them. That's actually pretty cool. Hey, Dan, are you drunk? I'll work on it. Beer for Dan. So certifications are about to show up, and not just for antiviruses, and if they discover this or that virus, or certifications for actual people, which we discussed. Hey, I'm a certified QA security engineer. 2 or 3 years down the road, this will happen, and they will know how to click next, next, next test. No, I'm not talking about QA in general. This is a very complicated subject. I'm serious. Do not belittle QA, but QA security needs to be as simple as it can be. So this is about certification, and hopefully it will show up. Now, another point is we don't actually need to have certifications. For example, a huge telco in the United States today told all the people who work with it, hey, Cisco, Juniper, you guys want to sell us your products? Well, we heard of this fucking Windows machine that I use for... Come on, guys, own me already! I bring this Windows machine with me since DEF CON 2005, and it hasn't been owned yet, to my knowledge. So maybe you're a litter than I think, maybe you just suck. And all I have to protect this machine is a very vulnerable Carrier firewall for 2002. Now, I'm serious, come on. Okay, certify your product, and use this further to do it. Dan fucking Kaminsky. Someone from 89.22, oh, whatever. Oh, you woke up now. Okay, certify your product using this or... Shut up! Okay. Someone using this or that fuzzer, use the fuzzer, test the product. If you pass and you have no problems, come to us. If you don't, fix them and then come to us. This is no actual certification, but it works. This commercial world of fuzzers has actually made a difference. And, well, that's pretty cool. Now, let's talk about it in the 3 minutes we have. And who wants to lead discussion, ask questions or whatever? Dan, shut up. He's cool, he loves me, but he will put me down, and I put myself down quite enough for this lecture, I think. So,
questions, comments, whatever?
Gary, you suck. You don't understand fuzzing in any way. It's all about writing this really cool fuzzer that will find all these really cool vulnerabilities that I have in my house, and I'm not going to show you because you're not lit enough. No?
Now, I have a question. I think, well, I'm not really sure what a good way would be to define those fuzzes. You mentioned you had those XML files defining the protocols. So basically you have a suite that takes a protocol definition and spits out code for a fuzzer specific to that protocol. Is there any generation tool for fuzzers?
Okay, actually, just on this specific point, XML is not perfect for defining a protocol for the fuzzer because it has no dependencies in it. And anytime protocols have dependencies of A to B to C again. But yes, being able to actually give the organization the tool. We have a framework that works, and hey, build your own protocols in. that works great. But as we said, integrating the security tools themselves into the development and QA process on the one hand, and having the actual people buy the product, and again, I edit in the topics, fuzz before you release, or on that particular point, fuzz before you buy. Then, actually, that's not what you asked, but whatever. Go ahead.
Yeah, right. I mean, my issue was...
XML, yes, that's cool.
Well, I doubt that. Now, I mean, my point is, getting good tests is difficult in normal test-driven development. I mean, at least that's my experience. Maybe I'm just stupid, but I think coming up with good tests is real hard. So if that could be automated, so that, well, whatever, the program just takes the input and then cooks up code that really does good tests that really do something, that would be helpful. And is there any software, and if it is there any software licensed freely so that people here could use it?
There's a lot of good fuzzers that are free that, came out recently. And all you have to do in order to get that figured out is go to blog search at Google and look for fuzzer, and you'll see, and sort them by date, and you'll see what's new, or just join the fuzzing mailing list, and whenever a new fuzzer comes out, it's announced. But yes, there have been some pretty cool open source fuzzers coming out lately that have really taken taken it a step further. But are they smart? Some of them are smart, but there is nothing you can do when commercial, I mean, fuzzing is basically in the realm of open source, but right now open source is behind, and commercial tools are actually a couple of steps further, but again, with a lot of money behind them. So.
I have a question for you, Gadi.
Okay.
The question is, have you worked with Windows Vista, and do you have any opinion about its security, especially in comparison to older products like Windows XP? That was my question.
I'll say just one thing before I give the microphone to Dan to answer that question, because he's here and he's a friend, and I allow myself to just give it to him. Does anybody know what ZERT is? Zero-Day Emergency Response Team? Okay, when we worked at ZERT and we tried to actually patch the VML vulnerability, we compared it against a lot of DLL files. And what we found was something that a few hundred people in the industry know, but pretty much nobody else does, and it's pretty obvious. Well, Microsoft and a lot of other vendors, such as, for example, Apple, or okay, one step at a time. There are a lot of patched vulnerabilities in Vista that are not patched in Windows XP. There are a lot of patched vulnerabilities in Windows XP Service Pack 2 that are not patched in Windows XP Service Pack 0 and 1. Meaning that if we take, for example, Vista DLLs, okay, not that Microsoft has not done some amazing things with security at Vista, but if we take Vista DLLs or IE7 DLLs and compare them with BINDIF, for example, to say XP DLLs or IE6 DLLs, we'll find many times that a lot of vulnerabilities just stare us in the face. And hey, we have new 0 days now. And looking at Vista when we patched VML, we noticed that 2 weeks before, or a month before the VML vulnerability came out as a 0 day in the wild, being exploited using WebAttacker, it was actually already patched within Vista. Now, that does not necessarily mean Microsoft hid that patch from the rest of us, because there are a lot of different groups within Microsoft that do this kind of stuff. But then we found out, hey, it's patched for 3 months now, so it's June. What the hey? And looking at the new DLLs at Vista, not just for vulnerabilities, but actually new code base, which we haven't covered before, is a very easy way to find vulnerabilities. And another example is that, for example, Apple, they just found a vulnerability in Apple that was patched with FreeBSD 6 years ago. So it's time for not just the security crowd to know that 0 days are easy to find, and not just by, say, looking for them, but for everybody else too. So the main contribution of Vista is we can find 0 days really easy now. But other than that, they have done some amazing stuff in Vista, but in my opinion, it's not the cure for the world, and vulnerabilities are still going to be here, and malware is still going to be here. And although it did take Microsoft a large step further, it's still pretty much the same operating system. And now Dan can answer your actual question, and the ZERT story was on the side. Oh, by the way, at ZERT, we actually checked DLLs for IE5, And guess what? For a brief period of time, 6 years ago, we were all secure against VML. IE5 for one version was secure, it was patched for VML. Then the patch was removed for some reason. So a lot of stuff we learned at Xert. Yeah, Dan fucking Kaminsky, everybody.
So I think you were asking, how secure is Vista? So I actually have some direct knowledge of this. I was part of their blue hat auditing team for Vista for most of the year. And, normally you walk into a pen test and it's like, could you please fix this? Oh, no. They got their ass kicked by security bugs way, way too much. So when they brought all of us in, it was more along the lines of, please point out anything you want fixed and we will fix it. And if we don't, here's a stick. And just start beating people until they fix it, and then it'll totally go get fixed. It doesn't surprise me at all that, the VML bug was fixed. We spent pretty much most of the bugs that were fixed in 2006 were security bugs. And, it was part of Vista. It was in box, so it was in the middle of getting reviewed. They did a really good job. And, if the worst thing you can say about Vista is, well, but they didn't patch it before. Well, what do you want? Do you want them to, we can't patch this bug because it's a bug, and then other people will see there's a bug. No, I'd rather they actually fix their problems, which I have pretty direct knowledge. Yeah, they've written a pretty solid operating system. Speaking of fuzzers, you don't actually get to ship anything in Vista if you don't have a fuzzer. Like, that code is 100% fuzzed.
Right? Microsoft, Cisco, they're actually doing it. So seeing the rest of the industry fall through is not that far-fetched.
Yeah, no, they're really pushing this entire software development lifecycle on all of their third parties because that's become the big problem. The operating system is all solid, the operating system is all secure, and meanwhile, what do customers do? They put on this third-party code and it's crap.
You lost the microphone when you said all secure. Okay, I'm serious.
Okay, I wouldn't say all secure. It's a hell of a lot better than the crap that insert third-party developers here.
So yes, I gave Dan the microphone because he can actually authoritatively say that Vista is better. Yes, absolutely, it is better with security. It has done a lot. It has patched a lot of bugs that are not patched before. We have heard that. And that said, come on, give me a break. Don't fall for the we solve the world problems, there are no more vulnerabilities or malware anymore, because please. So that's the only answer we can give you about Vista.